Tonight, I want you to imagine something. Not a new telescope, not a bigger mirror, a new rule for reality. What if the sky is not a background, but a living system that is constantly changing, constantly confessing, and constantly leaving clues? Rubin has begun releasing first looks from Cerro Pachón in Chile, and it already feels like the sky is talking. Thousands of moving rocks, galaxies stacked behind galaxies, dust clouds like fingerprints across the dark. This is not just a telescope. It is a surveillance camera for reality. Welcome to Void Therapy. Tonight, we are stepping into the moment the sky stops being a backdrop and starts being evidence. Rubin's power is not just its size, it is its rhythm. It returns to the same places again and again, building a living record of change. The observatory's mission is the LSST, the Legacy Survey of Space and Time, a 10-year time-lapse of the southern sky designed to catch motion, flickers, and rare events in bulk. That shift sounds subtle until you realize what it means. Old astronomy gave us portraits. Rubin gives us surveillance. And when you switch from portraits to surveillance, two things happen. You see what is beautiful, and you see what is hiding in plain sight. If Rubin watches the same sky on a tight cadence, what is the first thing it exposes that we were blind to? Maybe the universe was never quiet. Maybe our instruments were. And a quiet instrument can turn a living cosmos into a still life, then convince you that stillness is truth. The first thing Rubin exposes is movement at scale. Not one asteroid, not a handful, a swarm. Rubin released an early demonstration that stitched together 1,185 frames, showing asteroids sliding across the starfield like sparks in slow motion. And in roughly the first 10 hours of observing, tied to these first image releases, reports say Rubin identified over 2,100 new asteroids, including a small number of near-Earth objects that posed no threat. That is the impossible part. Not that asteroids exist, we already knew that. The impossible part is the scale and speed at which the sky starts giving up its movers once you can repeatedly scan huge areas with a serious camera. This is planetary defense, but it is also cosmic humility. Our solar system is not a neat diagram. It is traffic. If Rubin can reveal motion this easily, what happens when something moves in a way that does not match our expectations? When you watch the sky like a movie, you do not just find objects, you find behavior. Rubin is built for time-domain astronomy, meaning it is designed to catch changes, sudden brightening, fading, flaring, disappearing, reappearing. That includes supernovae, variable stars, active galactic nuclei, and the weird one-off flashes that normally slip between the cracks of slower surveys. Here is the retention hook that is actually real science. The universe produces rare events constantly, but we miss them because they are brief and unpredictable. Rubin's whole personality is, I will be back in a few nights. So imagine the future alert stream as a heartbeat. The sky pulses, something spikes, something dims, something moves too fast, something appears where nothing was. And suddenly, you are not just observing, you are responding. If Rubin starts catching new categories of events, what is the biggest mystery it is actually built to solve beneath all that flickering light? Rubin's endgame is not the bright stuff. It is the structure underneath it. Vera Rubin, the astronomer, showed that galaxies rotate too fast to be held together by visible matter alone. That mismatch pointed to dark matter, an unseen mass that makes gravity stronger than the light suggests. Rubin Observatory attacks this by measuring how matter is distributed across the universe using enormous samples of galaxies, and by tracking how their shapes and positions change statistically across cosmic time. Over the full survey, Rubin is expected to image on the order of tens of billions of galaxies and tens of billions of stars, which is exactly the kind of dataset you need when the thing you are chasing does not glow. This is the pivot from wow to wait. You do not need a perfect image of dark matter. You need a map of its consequences. If we map the invisible skeleton well enough, what else does that map unlock about the universe's future? Once you can measure large-scale structure across time, you can pressure test the biggest claim in cosmology: expansion, and whatever is driving it. Rubin's survey is expected to generate about 20 terabytes of data per night and build toward an archive on the order of hundreds of petabytes across the decade. That is not just a storage flex. That is what it takes to measure tiny statistical differences in how galaxies cluster, how the cosmic web evolves, and how expansion may have behaved across different eras. This is where dark energy enters the room. Dark energy is the name we give to the observation that the expansion of the universe is accelerating. The open question is whether that acceleration is constant, evolving, or a sign that our model is incomplete. Rubin's strength is consistency over time. The same sky, the same instrument, measured again and again. So what does any of this do to us, the people watching, when the sky stops being poetry and starts being a record we can replay? Here is the subtle psychological change Rubin brings. It turns the night sky into a dataset with memory. Before, the universe could surprise us and we would argue about whether we truly saw it. Now, the sky can be rewound. The frame is saved. The motion is measurable. The anomaly has receipts. And that does something to the human mind, even if you do not care about cosmology, because it moves you from belief to evidence, from wonder to witness. The one that ties it together. Maybe the most profound thing Rubin will map is not dark matter or dark energy. Maybe it will map our own ignorance in high resolution. Every night, it will show us a new way we were wrong, not to embarrass us, but to upgrade us. The universe does not change when we learn. We do. And that is the real rhythm shift. The first Rubin video was the promise. This is the consequence. A sky that moves means a sky that reveals. A sky that reveals means a universe that refuses to stay simple. Stay curious.